the Voyagers were guaranteed to work only until the Saturn encounter. I thought it might be a good idea, just after Saturn, to have them take one last glance homeward. While almost everyone is taught that the Earth is a sphere, with all of us somehow glued to it by gravity, the reality of our circumstance did not really begin to sink in until the famous frame-filling Apollo photograph of the whole Earth, the one taken by the Apollo 17 astronauts on the last journey of humans to the moon. It seemed to me that another picture of the Earth, this one taken from 100,000 times farther away, might help in the continuing process of revealing to ourselves our true circumstance and condition. It had been well understood by the scientists and philosophers of classical antiquity that the Earth was a mere point in a vast, encompassing cosmos. But no one had ever seen it as such. Consider again that dot. That's here. That's home. That's us.
This was Carl Sagan, the famous American cosmologist, astronomer, and writer, talking about the picture of Earth, known as the pale blue dot, taken by Voyager 1 as it traveled towards the edge of the solar system. More than 30 years after it was taken, this picture still reminds us not only of our fragility, but of the vastness of space. It was taken in 1990, just 33 years after the first ever man-made object was launched into space. Now, 30 years later, we have plans and timelines by which we might create settlements on the moon and other planets. I am Nikhil, and together with Arnab, we shall traverse through the genius ideas and often lucky missteps which allowed humanity to dream about escaping the small muddy island in a corner of the vast universe and put in place steps towards becoming a multiplanetary and interstellar species. Welcome to the second episode of Pursuit of Prosperity, and in this episode, we talk about space travel.
First up, Shubham. Where does the human interest in space begin? Can you take us on a brief tour of its history?
Early evidence for the human curiosity towards space begins with the development of astronomy. It is one of the old natural sciences. Civilizations as diverse as the Babylonians, Greeks, Indians, Egyptians, the Chinese, Mayans, and many different indigenous Americans made arduous methodical observations of the night sky. In the past, astronomy included many different disciplines, like celestial navigation, observational astronomy, astrometry, and even calendars. As early as the 6th century, Aryabhatta explicitly mentioned that the Earth rotates about an axis. He also mentioned that the reflected sunlight was behind shining the moon. Then in the 12th century, Bhaskara II correctly predicted planetary eclipses and the mathematics of planetary motion. He also gave the heliocentric theory. His 4-volume work, Siddhanta Shiromani, covering mathematics and astronomy, is an absolute masterpiece. He was also able to predict the length of a year, and it was so accurate that the value was only off by 1 minute. Unfortunately, he was never given much credit, and most of his work was either forgotten or credited to others. Then, more publicized breakthroughs were achieved during the Renaissance in Europe. Copernicus proposed a heliocentric model of the solar system. This was as yet unknown. His work was also defended by Galileo Galilei. They had to keep their correspondences a secret for a long time, so as not to endanger their lives. Their work was expanded upon by Johannes Kepler. Kepler was the first to devise a system that correctly described the details of the motions of the planet. Finally, it was Sir Isaac Newton who devised celestial dynamics and the law of gravitation. There we had arrived at the modern understanding of motion of planets.
From Copernicus to Kepler, People who shook up the traditional understanding of the world around us have generally been persecuted. With Newton's ideas, we now had a relatively solid understanding of planetary physics. But when did we figure out how to actually leave Earth?
The history of spaceflight starts with the story of Konstantin Tsiolkovsky. The life of Tsiolkovsky is an incredible story. He was the son of a Polish deportee to Russia. His mother died when he was just 13. He was self-schooled because he was hard of hearing. Eventually, he became a teacher at a school in a small town near Moscow. He came to believe that colonizing the space would lead to the perfection of human species, with immortality and a carefree existence. His most important work was published in May 1903 under the title Exploration of Outer Space by Means of Rocket Devices. He gave an equation to calculate the position and velocity of a rocket that's going to space while it is in vertical flight. He also made a significant calculation that the horizontal speed required for a minimal orbit around the Earth is 5 miles per second. If it were any slower, the object would fall down to Earth. By 1912, there was progress in spaceflight elsewhere as well. Robert H. Goddard was an American engineer who, in his spare time, had independently developed the Tsiolkovsky rocket equation. Most of the weight of a rocket comes from its propellant material. Goddard found that surprisingly small amounts of material would be required if the gases could be ejected from the rocket at a very high velocity. This meant that we could design rockets that could be launched with lesser propellant material. This was an interesting finding, and it still guides rocket design today. With these findings, he went and built the first liquid-fueled rocket. Essentially, Goddard had developed a rocket that would work in the vacuum of space. In late 1919, the Smithsonian published Goddard's groundbreaking work. In the same year, the New York Times came up with a demeaning article questioning Goddard's capabilities as an engineer. The article said that Goddard only seems to lack the knowledge that is ladled out daily in high schools. The New York Times was definitely wrong. It issued an apology, but it came 49 years later on the eve of Apollo 11, 24 years after Goddard had passed away.
It took genius minds to come up with the rocket equation, and the word rocket science is used as a metaphor for something really hard to understand. But what makes rocket science so hard?
Rocket science is a notoriously hard subject to grasp. Like you mentioned, whenever someone has to show something is difficult, they compare it to rocket science. It is because of the unintuitive nature of the engineering involved and the fact that the underlying physics is highly mathematical and hard to grasp. Just as an example, the common understanding is that rockets carries the space capsule in a straight line to the sky, while in fact, very soon after taking off, the rocket starts flying parallel to the Earth. This it does to get enough speed going around the Earth in order to get escape velocity. Thus, escape velocity is measured parallel to the ground, not perpendicular to it. The whole launch process can be understood with the help of a metaphor. Consider a pebble tied to a 1 meter long string. If you swing the pebble over your head, it will move in circles. Eventually, when the speed is high enough, the string will break and the pebble will be released from its orbit. It is very similar to what happens to a spacecraft.
That is indeed much more complex than it appears to be. So, when did he make our first breakthrough towards getting away from gravity?
World War II turned out to be a turning point for space travel. Germans were developing the V rockets. V stood for Vergeltungswaffen or retaliatory weapon. And it was a last-ditch attempt by the Germans to reverse the course of war. It was a dark time, and many prisoners were pulled from concentration camps for their technical skills such as welding. And they worked around the clock in an underground factory called Mittelwerk in central Germany. At the heart of the V2 was a powerful motor capable of taking the rocket more than 80 kilometers above the Earth in a trajectory of 190 kilometers. It was much more sophisticated than anything that had been built before, and effectively, it was the world's first space rocket. The key innovation was the use of automatic guidance systems and automated flight control. With the destination programmed into the onboard analog computer, once a rocket was in flight, its gyroscopes could continuously track the craft's position in 3 dimensions. Any deviations in course and rudders fitted on the fins on the side of the rocket would automatically adjust the heading and trajectory to keep it on target.
The Germans were on target in terms of rocket technology, but it's always the people behind the machine that matter. What happened to them after the war ended?
The Allies realized that the V2 technology was unlike anything that they had developed themselves. Not surprisingly, when the war ended, the Americans, Soviets, and British scrambled to get their hands on V2 technology. The engineer who designed the V2, Wernher von Braun, came to be feted as the hero of the space age. At the end of the war, he made a shrewd decision to surrender to the Americans and started working for the American Army on the Redstone missile, which was a direct derivative of the V2. The rocket later carried the US's first astronaut into space.
The Americans now had von Braun on their side, but wasn't the first human being in space a Soviet cosmonaut aboard a Soviet spacecraft?
In 1960, the Soviet Union chose 20 pilots to begin training for a human spaceflight. That group was narrowed down to the Sochi 6. Yuri Gagarin and German Titov were the final 2 potential spacemen. They were chosen not only for their excellence in space training but also for their short stature, since the cockpit was small. On April 12, 1961, aboard the spacecraft Vostok 1, Gagarin became the first human being to travel into space. During the flight, the 27-year-old test pilot and industrial technician also became the first man to orbit the planet. The triumph of the Soviet space program came in the thick of the Cold War. Putting the first man into space was a great blow to the United States, which had scheduled its first space flight a month later, in May 1961.
Carl Sandburg, the award-winning poet, once said, "The moon is friend for the lonesome to talk to." And in the epic love story Romeo and Juliet, William Shakespeare writes, "Do not swear by the moon, for she changes constantly. Then your love would also change." Khalil Gibran says, "We are all like the bright moon. We still have a darker side." Since time immemorial, humanity has looked at the moon with awe and wonder. Poets have eulogized its beauty. Children have wondered about a mythical rabbit that calls it home. And scientists have been curious about its structure and composition. It almost sounds inevitable that we'd one day aim to put people on the moon. But even to this day, more than 50 years later, the moon landing is seen as one of humanity's top scientific achievements. But what makes landing on the moon such a difficult endeavor?
First of all, we know that traveling into space is a complicated endeavor. Achieving enough velocity to leave Earth's gravity and building equipment to survive movement through Earth's atmosphere are by themselves 2 really hard challenges. But landing on the moon makes all this look like an absolute piece of cake. To get to the moon, a spacecraft must first leave Earth's gravity. Upon approach to the moon, a spacecraft will be drawn ever closer to its surface at increasing speeds to the moon's gravity. In order to land intact, it must decelerate from around 3,500 km per hour to less than about 160 km per hour and be ruggedized to withstand a hard landing impact. And if we want to bring a spacecraft back from the moon, which is mandatory if there are human beings on board, the spacecraft must be capable of returning back.
Definitely, nobody would like a one-way trip to the moon.
True. If there are human beings on board, hard landing is definitely not an option. It must decelerate to a negligible speed at contact for a soft landing. To return back to Earth, rockets must be used to leave the moon and return to space. Upon reaching Earth, special techniques should then be used to reduce its speed for safe landing. So putting it all together, for a human mission to the moon, A moon departure rocket must first be carried to the moon's surface by a moon landing rocket, increasing the latter's required size. The moon departure rocket, the larger moon landing rocket, and any Earth atmosphere entry equipment, such as heat shields and parachutes, must in turn be lifted by the original launch vehicle, greatly increasing its size by a significant and almost prohibitive degree.
Landing on the moon seems to be way harder than launching into space. So, why did we want to put human beings on the moon in the first place when it seemed almost impossible? Were there other driving factors?
The romantic answer to that question would be to say that landing on the moon was a natural part of the progress of the human race. It was eventually going to happen, given humanity's passion and curiosity, and every other event or action that drove it was just an accompanying instrument in the great orchestra of time and fate. True as it might be, that the moon landing took place in 1969 owes a lot to the space race between the two powers of the 20th century, Soviet Union and the United States. In an attempt to one-up each other and demonstrate to the world that communism was better than capitalism or vice versa, the Soviet Union and the United States chose space as their battleground. By the early 1960s, Soviet Union had thoroughly overtaken the United States in the space race. It had put the first object in space, first living being in space, first human being in space, and also achieved the objective of putting the first man-made object on the moon when it successfully crash-landed Lunar 2 on the moon in 1959. President Kennedy wanted to win the Cold War and demonstrate American and capitalism superiority to the world. And in 1961, he made an appeal to a special joint session of Congress.
First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Thereafter, a space mission began in the United States on a warlike scale. For the next 9 years, there would be relentless effort, and the United States would stop at nothing to put the first human beings on the moon.
It seems like landing on the moon had become a matter of prestige rather than something that was purely driven by scientific curiosity. So, what followed?
Landing humans on the moon by the end of 1969 required the most sudden burst of technological creativity and the largest commitment of resources ever made by any nation in peacetime. An existing space program called the Apollo program was restructured with the goal of putting human beings on the moon. At its peak, the Apollo program employed 400,000 people and required the support of over 20,000 industrial firms and universities. There were 12 crewed Apollo missions in total. Apollo 1 ended in a tragedy with the crew perishing in a fire that started in the command module during a launchpad test. The missions 2 to 10 progressively tested all capabilities needed to land on the moon. Apollo 7 was sent to Earth orbit, 8 was a circumlunar flight, 9 tested the lunar module and the life support system, 10 was a dress rehearsal for the lunar landing, with the landing module descending to 15.6 km from the lunar surface. Finally, 11 was the actual landing mission. Neil Armstrong, Michael Collins, and Edwin Buzz Aldrin manned the Apollo 11 mission. They became instant celebrities and got their names etched in history. Following the success of Apollo 11, 6 more missions to the moon were undertaken under the names of Apollo 12 and 17.
Now that man had landed on the moon, not once, but 7 times, what was next on the agenda?
In 1964, researchers at NASA identified that in the late 1970s, a periodic alignment of the outer planets would occur, which could enable a single probe to visit Jupiter, Saturn, Uranus, and Neptune. So NASA began work on a grand tour program, which subsequently evolved into the Voyager missions. Launched in 1977, Voyager 1 originally involved traveling to Jupiter, Saturn, and Saturn's moon Titan. Voyager 2, on the other hand, also involved traveling to Jupiter and Saturn, but the rest of its trajectory was to be determined by Voyager 1's status. If Voyager 1 was successful, as it turned out to be in real life, Voyager 2 would be redirected to Uranus and Neptune, else it would try to visit Saturn's moon Titan. The Voyagers have made immense contributions to science and human understanding of interstellar space, and more than 40 years and 15 billion kilometers later, they are still in contact with Earth. But one of the most interesting parts of the Voyager missions is the Golden Record. It represents humanity's attempt to be a part of the interstellar community. The Voyager Golden Records are 2 phonograph records that were included aboard both Voyager spacecraft. The records contain sounds and images selected to portray the diversity of life and culture on Earth, and are intended for any intelligent extraterrestrial life form who may find them. The records are sort of a time capsule. Each record is encased in a protective aluminium jacket, together with a cartridge and a needle. Instructions, in symbolic language, explain the origin of the spacecraft and indicate how the record is to be played. The contents of the record were selected for NASA by a committee chaired by Carl Sagan. They assembled 115 images and a variety of natural sounds such as those made by surf, wind, thunder, birds, whales, and other animals, and spoken greetings from Earth people in 55 languages. It also included printed messages from President Carter and the United Nations Secretary General Waldheim. There is an eclectic 90-minute selection of music, including both Eastern and Western classics, and a variety of ethnic music. The cover of the Golden Record not only contains instructions on how to play the record, but it also has a small patch of ultra-pure source of uranium-238, which acts as a radioactive clock.
Amazing! The Golden Record about the Voyagers seem like the interstellar equivalent of a message in a bottle, and the mission themselves are a testament to human curiosity and passion. Perhaps one day our interstellar neighbors will be able to fish out the Golden Records from the vast ocean of nothingness and be our BFFs. This was happening in the 1970s. What followed a couple of decades later would be something science fiction writers in the 19th and early 20th century could only dream about.
If you look up at the sky during dawn or dusk, you might sometimes see a bright spot moving across the sky. This bright spot represents one of humanity's greatest engineering accomplishments. Jishnu, can you tell us more?
If you've ever read some science fiction, you'll probably have heard some stories about human beings living on spaceship. You would have read about their daily habits, their troubles, and their awe at the spectacular view from the windows of the spacecraft. The bright spot that we can sometimes see in the evening sky is an embodiment of all these very ideas, and it's called the International Space Station. The ISS is a humongous spacecraft in orbit around the Earth at an altitude of approximately 400 kilometers. It is a brilliant example of post-Cold War collaboration among various countries involving the USA, Russia, Japan, Canada, and the European Space Agency. In fact, it's the largest artificial object in space, and it is regularly visible to the naked eye from the surface of the Earth.
So what do they do on the ISS?
Researchers from various governments, industries, and educational institutions use the facilities on the ISS to conduct experiments in microgravity. Long-term exposure to weightlessness has effects such as decreased muscle strength and osteoporosis, which are very similar to aging. This gives us new insights into the process of aging and also the associated treatment. The ISS astronauts also test ecological life support systems. They grow various plants that release oxygen, absorb carbon dioxide, and provide food. This is something of a small-scale experiment of what we hope to do in the future, when we do become an interplanetary species and have to do the same when we make a trip to Mars. Crew members can also use telescopes to observe the sun, stars, and the galaxies without distortion from the Earth's atmosphere.
I believe the crew must be spending quite some time to run those experiments up there. What is it like living in space?
For the last 2 decades, the ISS has constantly sustained the presence of astronauts and even the occasional visitor. Human beings who live aboard the ISS follow an extremely rigorous schedule of daily chores, maintenance, exercise, and some leisure time. Living in space does come with its own set of challenges. Here on Earth, we take gravity for granted, but in space, people have to retrain their mind for weightlessness. An astronaut aboard the ISS once said, "The first time I tried typing on the keyboard, I launched myself to the ceiling." Even day-to-day activities like going to the toilet can be very difficult. Space toilets do not use water. Instead, the astronauts must first fasten their seatbelts to the toilet seat. A lever operates a powerful fan and a suction hole slides open and the air stream carries the waste away. Apart from the device itself, they have to get accustomed to the disconcerting fact that their bowels actually float inside their bodies, like the rest of their internal organs, and of course, everything else on board. But it's not all bad. Having food in space can be pretty fun. Since the taste buds are dulled by the weightlessness, astronauts prefer really spicy food. The food floats in the air, water forms floating bubbles, and you don't have to worry about the food falling on you and staining your dress. Everything has a silver lining. But the best part of living on the ISS is the view. The view from the ISS windows is absolutely breathtaking. You can view the gorgeous aurora borealis, cyclones, tornadoes, brightly lit cities, and frosty mountain peaks in their almighty glory. It's something that only 291 people have ever experienced, and only a few more will in the future.
That sounds like a trip that everyone would like to take at least once, but I feel all of this must be coming at a price. Is it worth spending so much when people are dying on Earth out of hunger?
Sadly, that's an often repeated false dichotomy. There's enough money and there are enough resources on this planet to solve both hunger and to fuel space exploration. The United States in 2020 spent less than 0.5% of its entire budget on NASA. Space exploration not only inspires humanity and increases our understanding of where and who we are, but has also led to the development of a lot of technology we use in our day-to-day lives. For example, solar panels were developed by NASA. In the vastness of space, they collect electricity by absorbing light when it strikes the surface and transfers it to a semiconductor. These solar panels are now used on calculators, streetlights, houses, etc. To keep missions on time, General Time Corp developed electrically stimulated quartz crystals. Quartz provides a stable time base, giving clocks an accuracy of 1 minute a year. These clocks keep millions of people on time all around the world. Under NASA contract, a chemical process was developed to remove toxic waste from used dialysis fluid. And this discovery led to the development of a kidney dialysis machine using sorbent dialysis, which is a method of removing urea from human blood. The process saves electricity and gives the patient greater freedom of movement during their treatment. And this is just the tip of the iceberg when it comes to how technology on Earth has been influenced thanks to space. Space exploration allows humanity to look beyond the Earth, to look at the stars and aim higher. It continues to inspire generations and will do so for generations to come. And when the Earth becomes uninhabitable in the future, it is our species' only hope.
The strides we've made in the last century, and specifically the last 5 decades, are almost unrealistic. We know much more about space and we've been farther than we ever did before. Researchers believe that a Crude-based research station on the Moon could become a fuel depot for deep space missions and make it easier to get to and live on Mars. The Artemis Lunar program is NASA's attempt to return to the Moon. Companies like SpaceX and Blue Origin are competing to provide their services of commercial lunar payloads. SpaceX's Starship, which started development in 2016, is a fully reusable transportation spacecraft designed to carry both crew and cargo to the Moon, Mars, and beyond. It will be the world's most powerful launch vehicle ever developed and could launch crewed missions to the Moon in the next few years. NASA believes that this would be the first step in sending humans to Mars. Investors are eager to get in on the action, thanks to the successes in the past decade pushing the industry forward. In the next few decades, humanity is staring at the very real possibility of becoming an interplanetary species. A species that has the privilege of not only calling one planet home, but multiple with the possibility of adding more. We as a species have been driven to explore the unknown and to push our scientific limits, and reaching Mars is just the beginning. Key sources for this episode include NASA's online repository of mission data and knowledge bases. How and why SpaceX will colonize Mars, a blog by Tim Urban. For an exhaustive list of sources, please visit anchor.fm/Pursuit of Prosperity. Pursuit of Prosperity is a fortnightly podcast written and produced by Shubham Vyas, Jishnu Chandar, Arnab Das, and me, Nikhil Nagraj. If you like the show, please remember to share, rate, and review.